Okay, today we're going to do inverses on graphs and tables. So we're going to skip this top part and we're going to come back to that next week. So we're going to start right here and we're going to talk about how to do inverses of graphs. So for an example, we're going to do f of x equals x squared plus 5. And we know what that looks like. That looks like a quadratic. So first it says graph the function. So this is a quadratic equation. We could do this one in point slope form. So in point slope form, we learned that this is y equals a x minus h squared plus k, where h and k is the vertex. Or if you've forgotten that method, you could just even make a little table and plug in some points and see what you get. So let's plug in -2, -1, 0, 1, 2, because those are super easy to plug in. -2 squared is 4, plus 5 is 9. 1 squared is 1 plus 5 is 6. 0 gives us 5. 1 gives us 6, and 2 gives us 9. So I can really easy graph it just making a table even if I don't remember how to graph it this way. So I'm going to graph -2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right there. 9. And I also have 2, 9. I have 1 and 6. And -1 and 6. And 0 and 5. So here's my graph on my first one. There's my graph. I graphed it. All right. Then we're going to find the inverse. And when we're graphing, the whole thing is that we switch the x and y when we graph. So instead of 0, 5, I'm going to have 5, 0. So I'm going to graph it over here. 1, 2, 3, 4, 5. Instead of 1, 6, I'm going to have 6, 1. Instead of 2, 9, I'm going to have 9, 2. We're going to just ignore this line where they say, is the inverse solvable? We're going to ignore that on this worksheet. Okay, so we're going to find this inverse function by just graphing today. We'll find the equations, as I said, we'll do the equations next week. But here's where it's going to graph. Now, if I graph the other side, I've got -1, 6, so 6, -1. -2, 9 is 9, -2. So if I graph this, it says, is the inverse a function? Is this a function? No, because it fails the vertical line test. It fails the vertical line test, so the answer is no. Now, where is this? This is a reflection, but where is this a reflection? This is a reflection over the line, over this line. If I folded my paper right on this line, they would match up. And this line right here is the line y equals x. So when we're graphing them, I can just switch the x and y, or I can think about it that it's folded on this line here, and what's on that side will come over here. All right, so on the other paper, let's do a couple of examples on the other paper. We're going to start off with the definition of what an inverse is. An inverse is a function and we use the term f at negative, we put a little -1 like that, x, found by switching x and y in f of x. So I take whatever my function is, f of x, I just switch the x and y's, and I get the inverse function, and this is how we write the inverse function. Now, we've already talked about one-to-one before. A one-to-one passes horizontal line tests they're is only 1 y for every x. And we already did the 1-to-1 before. We're just reminding us. If it's 1-to-1, if our original function f of x is 1-to-1, our inverse will be a function. If it's not 1-to-1, our inverse is not going to make a function. So we're going to do some graphs here. I just said that we can think about this as being a reflection across this line, or we can think about it of just swapping the x and y. So let's pick some points that we're going to fill in our table from up here. This point is at -9 and -2. This point is at -8 and -1. This point is at -5 and 0. This point is at 0 and 1. And we have another point right here at 7 and 2. In order to graph the reflection, I can just switch these. So I'm literally just taking these and switching these. So this will be -2 and not -9, -1 and -8, 0 and -5, 1 and 0, 2 and 7. Then I can graph these to get my reflection. -2 and -9 is right here. -1, -8 is right here. 0, -5, 1 and 0, and 2 and 7 right here. And when I connect those, does this fold along this dotted line? It does. The domain and the range also get swapped. So let's do the domain of our original one. Let's remember domain. This one is starting at -9, and then just pretend these have arrows on them. This is starting at -9 and then goes all the way to positive infinity in the domain this way. So this is, the domain is -9 to infinity. And the range of this one starts here at -2 and goes up to infinity. Well, if we just swap the x and y to get this, then we also swap the domain and range. So the range of this one becomes the domain of this one. And let's see if that works. The domain is going this way. It's from -2 to positive infinity. And that's the range. -2 to positive infinity. And then the range is going to be the same as the domain of that one. So the range of this one starts at -9 and goes to infinity. All right, then we got one more example here. This one, let's graph our points here. -5, -4, and -9. I'm going to do this one a little faster on the video. Just going to put in my points. And let's do the domain and range of this one before we do the other one. So this one is less than 0 for the range. So from 0 down for my range, and let's pretend these have arrows. And then for my domain, it's going to be all real numbers. Okay, for my other one, I'm just going to swap the x and y. So this is going to be -9, -4, -6, -2, 3, 0, 0, 2, -3, 4. I just swapped my two columns here. I swapped it. So it's going to be here. And it's going to go out -9, -4, -6, -2, 3, these should be negative, 3, 0, 0, 2, and so it goes like that. Again, is this a reflection over this line, y equals x? Yes, it's reflected, folded right over this line here. There it is. And then my domain and my range will be switched. And this one, my domain is less than 0, 0 to infinity, and my range is all real numbers.